Welcome to this lab. In this lab, we're going to look at Vertex AI Pipelines Quick Start. The overview here is the pipelines help you to automate and reproduce your ML workflow. Vertex AI integrates the ML offering across Google Cloud into a seamless development experience. Previously, models trained with AutoML and custom model were accessible via separate services. Vertex AI combines both into a single API, along with other new products. Vertex AI also includes a variety of MLOps products like Vertex AI Pipelines. In this lab, you will learn how to create and run ML pipelines with Vertex AI Pipelines. So why are ML pipelines useful? Because imagine you are building out an ML workflow that includes processing data, training a model, hyperparameter tuning, evaluation, and model deployment. Each of these steps may have different dependencies, which may become unwieldy for you to treat the entire workflow as a monolith. As you begin to scale your ML process, you might want to share your ML workflow with others on your team so they can run it and contribute the coding. Without a reliable reproducible process, this can become difficult. With the pipelines, each step in your ML process is in its own container. This lets you develop steps independently and track the input and output from each step in a reproducible way. You can also schedule or trigger runs of your pipeline based on the events in your cloud environment, like when new training data is available. So let's start with the task 1. Open the notebook in Vertex AI Workbench. So we click on the Workbench. You can type in Workbench here in the text box. And then this is the instance name we have at the moment. I will click Open Jupyter Lab button. This will open the Workbench instance in a new browser tab. There are a few additional libraries you need to install in order to use the Vertex AI pipeline. And they are Qwik pipelines. This is the SDK used to build the pipeline. Vertex AI pipelines support running pipelines built with both Qwik pipelines or TFX. Google Cloud Pipeline Component. This library provides pre-built components that make it easier to interact with Vertex AI services from your pipeline steps. Let's start with clicking this Python tree to launch a new Python notebook. You can rename the notebook with a meaningful name. So let's call this as Vertex AI rename. Yep, you can see the new name over here. First, we need to install both services needed for this lab. First, set the user flag in the notebook cell, in this case, this one, and then you run it. Then run the following from your notebook. Maybe you will see some warning and error regarding the version, which you can safely ignore. How do you know it's finished? If you see this number, if there's a numeric number that appear here, that means it's already completed. After you install this package, you need to restart the kernel. I'll type in this code here. This will help you to restart the kernel. Finally, check that you have correctly installed the package. Let's run this. So the KFP SDK version should be more than 1.6. Yeah, this is 1.8. It's fine. Now step 2, we're going to set up your project ID and bucket. Yep, we already done that setting. Now we create a variable to store the bucket name. Step 3, we're going to import the library. Yeah, it's done. And step 4, we need to define the constant. The last thing you need to do before building the pipeline is define some constant variable. Pipeline root is the cloud storage path where the artifacts created by your pipeline will be written. You are using US Central 1 as the region here, but if you use a different region when you create your bucket, update the region variable in the code below. Moving on to the task tree, we will create our first pipeline. We will create a short pipeline using the KFP SDK. This pipeline doesn't do anything ML related. In this exercise, we will teach you how to create a custom component in the KFP SDK and how to run and monitor the pipeline Vertex AI pipeline. You will create a pipeline that print out a sentence using two output, a product name and an emoji description. This pipeline will consist of 3 components. Product name, the component will take a product name as an input and return that string as output. Emoji, this component will take the text description of an emoji and convert it to an emoji. For example, the text code for this is sparkles. So this component uses an emoji library to show you how to manage external dependency in your pipeline. Then the third component is the build sentence. This final component will consume the output of the previous 2 to build a sentence that uses the emoji. For example, the resulting output might be Vertex AI pipeline is this emoji sparkles. So we will add the following. First, build the product name component, which simply take a string as an input and return that string. If you take a closer look at the syntax here, the alias component decorator compiles this function to a component when the pipeline is run. You will use this anytime you write a custom component. The base image specifies the container image this component will use. The output component file parameter is optional and specify the YAML file to write the compile component to. After running the cell, you should see that file returned to your notebook instance. If you wanted to share this component with someone, you can send them the generated YAML file and have them load it with the following. This done. So the string here after the function definition specify the output type for this component. Now go to the step 2. We're going to create 2 additional components. So to complete the pipelines, create 2 more components. The first one takes a string as an input and convert this string to its corresponding emoji if there's one. If it returns a tuple with the input text pass and the resulting emoji. So the component is a bit more complex than the previous one. Here is what is new. The package to install parameter tells the component any external library dependency for this container. In this case, you are using a library called emoji. This component returns a named tuple called output. You use this in your next component to access the output. So you notice that each of the string in this tuple have a key, emoji text and emoji. The final component in this pipeline will consume the output of the first 2 and combine them to return a string. This one. You might be wondering, how does this component know how to use the output from the previous step you defined? Good question. You will tie it all together in the next step. So moving on to step 3, putting the components together into a pipeline. The component definition defined above created factory function that can be used in a pipeline definition to create steps. To set up a pipeline, you use the dsl.pipeline, give the pipeline a name and description, and provide the root path where your pipeline artifact should be written. By artifact, it means any output file generated by your pipeline. So this intro pipelines doesn't generate any, but your next pipeline will. In the next block of your code, define the intro pipeline function. This is where you specify the input to your initial pipeline step and how the step connect to each other. So the product task takes the product name as an input. Here you are passing Vertex AI Pipelines, but you can change this to whatever you like. Emoji task that takes the text code from an emoji as an input. You can also change this to whatever you like. For example, party face refer to the party face emoji. Note that since both this and product task component don't have any step that fit input into them, you manually specify the input to this when you define your pipeline. The last step in the pipeline is consumer task that has 3 input parameters. The output of product task, since this step only produce one output, you can refer it via the product task output. The emoji output of the emoji task step, see the emoji component defined above where you name the output parameter. Similarly, the emoji text name the output from the emoji component. In case your pipeline is passed text that doesn't correspond with an emoji, it will use this text to construct a sentence. Okay, so this is the one that we just go through. So you can change the text and emoji string parameter here to update your pipeline output. Step number 4, compile and run the pipeline. Well, with your pipeline defined, you are ready to compile it. So this following will generate a JSON file that you will use to run the pipeline. Next, instantiate an API client. This one. Yeah, I have corrected the code here. Okay, finally run the pipeline. So running the pipeline should generate a link to view the pipeline run in your console. It should look like this when complete. Okay, you can click this link here. It should look like this when after you click the link. This pipeline will take 5 to 6 minutes to run. When complete, you can click on the build sentence component to see the final output. So you can know when this is complete or not by looking at this status here. Okay, so finally all the steps are completed. You can also see from here. Okay. Now let's check my progress. Yeah, it's completed, and move on to the task 4. We will create an end-to-end ML pipeline. It is time to build your first ML pipeline. In this pipeline, you will use the UCI machine learning by dry-beans dataset from Qwik and Cochrane, multi-class classification by dry-bean using computer vision and machine learning techniques in computers and electronics in agriculture. This pipeline will take over 2 hours to complete. You will need to wait for the entire durations of the pipeline to complete the lab. Follow the step until your pipeline job has started. So this is a tabular dataset, and in your pipeline you use the dataset to train, evaluate, and deploy an AutoML model that classifies the beans into 7 types based on their characteristic. So the pipelines will create a dataset in Vertex AI, train the tabular classification model with AutoML, Get evaluation metrics on this model. Based on the evaluation metric, decide whether to deploy the model using conditional logic in Vertex AI Pipelines and deploy the model to an endpoint using Vertex AI Prediction. So each of the steps outlined will be a component. Most of the pipeline steps will use pre-built components for Vertex AI service via the Google Cloud Pipelines component library you imported earlier in this lab. In this session, you will define one custom component first, and we will define the rest of the pipeline step using the pre-built components. Pre-built components make it easier to access Vertex AI services like models training and deployment. The majority time for this step is for the AutoML training piece of this pipeline, which will take about an hour. So step 1, a custom component for model evaluation. The custom component you will define will be used towards the end of the pipeline once the model training has completed. The component will do a few things. Get the evaluation metric from the train AutoML classification model, pass the metric and render them in Vertex AI Pipeline UI, compare the metric to a threshold to determine whether the model should be deployed. Before defining the component, you understand its input and output parameter. As the input, this pipeline takes some metadata on your cloud project. The resulting train model you define in this component later, the model evaluation metrics and the threshold. The threshold dictionary string is something you will define when you run in your pipeline. In the case of classification model, this will be the area under the ROC curve value for which you should deploy the model. For example, if you pass in 0.95, that means you would only like your pipeline to deploy the model if this metric is above 95%. So the evaluation component returns a string indicated whether or not deploy the model. So let's add the following into the cell now. This is the whole coding that I just paste. And then I run it. Yeah, it's done. And step 2, adding the Google Cloud pre-built components. First, define the display name of your pipeline run using a timestamp. Okay, then I will copy this following into these cells and run it. Yeah, it's done. What is happening in this code? First, just as in the previous pipeline, you define the input parameter this pipeline takes. You need to set this manually since they don't depend on the output of each step in the pipeline. The rest of the pipeline use a few pre-built components for interacting with Vertex AI services. Tabular dataset create a tabular dataset in Vertex AI given a data source either in cloud storage or BigQuery. In this pipeline, you are passing the data via a BigQuery table URL. So auto tabular training job run out kicks off an AutoML training for tabular data set. You pass a few configuration parameters to this component, including the model type, in this case classification, some data of the columns, how long you like to run training for, and a pointer to the dataset. Notice that to pass in dataset to this component, you provide the output of the previous component via dataset create ops output dataset. Next, model deploy op deploy a given model to an endpoint in Vertex AI. There are additional configuration and options available, but here you're providing the endpoint machine type, project, and model you like to deploy. You're passing in the model by accessing the output of the training step in your pipeline. This pipeline also makes use of conditional logic, a feature Vertex AI pipelines that let you define a condition along with different branches based on the result of the condition. Remember that you define the pipeline, you use a threshold dictionary string parameter. This is the accuracy threshold you are using to determine whether to deploy your model to an endpoint. To implement this, make use of the condition class from the KFP-SDK. This condition passed in is the output of the custom evaluation component you defined earlier in this lab. If the condition is true, the pipeline will continue to execute the deploy op component. If accuracy doesn't meet the predefined threshold, the pipeline will stop here and won't deploy the model. Step 3, compile and run the end-to-end ML pipeline. So we copy this code and paste here and run. It's done. Next, kick off the pipeline. So you can click on the link again. The link will show after running. After you click the link, the pipeline will take a little over an hour to run. So there are 5 steps to complete here. You can also toggle on the expand articles. Okay. You will be able to see details for the different artifact created from your pipeline. For example, if you click on the dataset artifact, you can also click on the link here to go to the dataset, which is inside your cloud storage. I can also mark this assessment as completed. So step 4, you can compare the metrics across pipeline run. Okay, so this is the way that you can do the comparison. You have now learned how to build and run and get metadata for an end-to-end ML pipeline on Vertex AI Pipelines. Congratulations! You can end the lab now.